Test. All right. I think we can start. So, welcome everybody to my talk about a practical guide for crafting resilient UI components. First of all, hey, Copenhagen, Denmark. It's my first time here in Copenhagen, Denmark. And actually, who from you is from here? Anyone from here? Who is from Denmark here? Okay. Who is from outside Denmark? The same. Wow, crazy. Yeah, I came a couple of days earlier when I arrived here, and I did actually the most touristy things you can ever do. And I tried some of these smorgasbord abroad, I guess you could say, and they were really good. So basically 10 out of 10. I also did a lot of biking and things like that. And yeah, for the ones actually that are from here or know this place very well, I'll be staying until the end of the week. So I'd be curious to know from you what your favorite food here in Denmark is and what I definitely should not miss. So before to talk about UI components, I'd like to quickly introduce myself. My name is Glenn, and I'm from Vienna, Austria. I have Philippine heritages, so I look like Filipino, obviously. So you can find me also at Glenn Reyes, but without the E's, on all the social media channels, including X, or formerly known as Twitter, LinkedIn, or Instagram, or basically anywhere. I'm the head of developer relations at Cadena, which is the only layer 1 multi-chain blockchain that actually scales. And I'm super, super thrilled to be there to advance their front-end and React ecosystem and community, where I can work with all the tech that I'm really, really passionate about, like React, GraphQL, TypeScript, and design systems. Now, let's talk about building UIs. So personally, I have found building UIs a super, super positive task to do. And like, it's one of the things that I really, really enjoy and care a lot about, which is also at the same time a super challenging task to do, especially when it comes to building robust UIs. And it's similar to things where I'm like, okay, I want to create this thing, I want to create this new project. Maybe let's create a video and put a lot of effort inside of it. Or I'm really passionate about also playing music. So let's create a track or something. And it's so beautiful, right? So, but once you're forced to give more thoughts into something that you're really, really passionate about and more effort into it, you're not just like making not just like making this thing or the UIs, but you want to make it really, really thoughtfully and for UIs robust. And then there's a bunch of challenges to think of. So maybe let's take a step back and begin with the question with what is actually robust. So I'd break this down into some key things that I've highlighted here that I found really, really important when thinking in robust UIs. So first is, for example, API design. So a well-designed API with a minimal surface area makes a component robust by exposing only the essential props, methods, or events, basically to simplify the integration and reduce the possibilities of errors and easing the long-term maintenance. Second, it should be adaptable and flexible and should allow for easy customization through props, making it reusable across various parts of applications or various applications. Also, robust UI components should be accessible to all users, including to those who rely on assistive technologies, for example, like screen readers. So things like area attributes or keyboard navigation are some of the features that can help make a component or make your application more accessible for them. A robust component should also be designed to handle errors gracefully. For instance, if a component relies on data from an API, it should be able to handle scenarios where the API is unavailable or return incorrect data. A robust UI component should be optimized for performance. So slow or very heavy intensive UI components, like think of big charts or like huge large tables, can result in like a poor user experience very quickly. As for testing, not only unit tests, but also integration tests and end-to-end tests. So testing frameworks and tools that can simulate a variety of conditions under which a UI component must operate reliably. Also, it's important, to incorporate fallback or default states. So, for example, if you have if you display a default or a fallback avatar when the user's profile's image is fails to load. And as for documentation, describe how they should be used. What limitations they have. Think of writing down some conventions and how to handle various edge cases. And yeah, by paying all of these different key factors, developers can basically create UI components that are not only robust, but also can reduce the possibilities of bugs while improving the user experience and ultimately save development time in the long run. So building new user interfaces come with certain foundations. So to me, I think what makes me feel real comfortable and productive to start building UIs is by getting first the right tools in place, and then the theming and the design systems specified, and the key strategies and approaches of actually building them. So let's talk a bit about tooling first. So before we start building something, we need tools, and we don't need just build or set up any tools, but it's really helpful if we can get really good tools, and ideally the most effective tools. So the better the tools are, the better the developer experience will be, and therefore the better quality output we get and results we tend to get. So better tooling help us move faster and with the most reliability as possible. And we don't only need tooling to help our code base clean, but also keep our code base clean without much work from us developers required. So anything that can be automated or auto-fixed without us requiring to do anything are like really foundational things that help us achieve building more robust user interfaces. So fundamental tools, I'm sure pretty much everyone of here has heard of them, are things like formatters or linters, whether they are like ESLint or Prettier or Rome. These are like super straightforward choices for most applications, and I think these are like really foundational tools that are super indispensable, and definitely one of the things you first want to set up before start building your project. So these aren't supposed to just set you guidelines and rules for certain things, but I think more relevant, in my opinion, is when they find and actually fix any syntax or problems automatically in the code without you doing any effort. So I'm a huge fan and had only good experience with source code that is basically deterministic. So what do I mean by that? One of my favorite examples is actually to do some sort of things that can auto-sort your code. So it doesn't have to be in this case in an alphabetical order, but it can be anything as long as it's in the same order based on your current rule you are defining. So it could be some grouping that you want to have that particular thing be ordered or on things like that. So I understand that also auto sorting is often not really desired or not encouraged, because it somewhat enforces a predefined grouping that isn't necessarily like the best case for each and every case. Deterministic code, in my opinion, increases maintainability and consistency in the code. And the simple example would be, sorting anything that can be sorted automatically without problems by its alphabet. And this way you'll get deterministic code, which makes it more reliable, predictable, and consistent. yeah, as for ESLint, here's a config that I keep using for all my projects called ESLint config banana. And with this, you basically get all the auto-fixable rules and better included things, better included, and it's also open source on GitHub. So basically, you can check it out. I try to keep it maintained as good as I can. And what's also worth to note is that when you want to enhance your linting with type information through TypeScript, it can be super useful, for automatically getting types and orders in the way you want. And this only needs a reference to your tsconfig JSON by adding so either true or the path to your tsconfig JSON to parser options.project. Two really good prettier plugins that have only good experience with are prettier plugin sort imports by Trivago and prettier plugin Tailwind CSS, given you are using Tailwind CSS. So they both help with sorting your import statements, and as for Tailwind CSS with your utility class names. So it's super neat and yeah, worth to check them out. Pretty sure they have also saved me a lot of time in development already. You probably don't want to build user interfaces inside your app because oftentimes there can be components that are deeply nested inside of states until you reach them. So not to mention very rare or very complex states that you barely reach. So make sure to build components in isolation. So I have put here some of the most established component explorers, I think, here, including Storybook, React Cosmos, Ladle, etc. And basically, they all can help build components in isolation very conveniently. And yeah, personally, I've worked with Storybook for most of my projects, but I'm seeing more and more folks using alternatives too, like Ladle, because it's very friendly to projects that are built on top of Beat, for example. And yeah, especially Storybook have helped me to control the states with the knobs very conveniently. And these tools are also very perfect to document and to collaborate with product managers and even designers to yeah, sync with the design system, basically. One thing that I really encourage also is you want to make sure that you cover all the different states of every single component. And what I like to do is I like to try to show all the different states at once, for example, on your favorite component explorer. So you really want to make sure you cover all the different states and make sure they sit perfectly and there is no outlier or anything. And yeah, to boost your confidence with all of these, set up automated tests. Even it's sometimes controversial, as they are super valuable on the component level as well to keep the integrity of the interface and to increase confidence reliability, especially when adding updates to the UI code base. So there is not much work involved, I have to say. But yeah, there's tools that can help you really make them very quickly, even if it's just smoke tests or just checking the dimensions or anything. So things like Cypress comes with a built-in feature that helps with creating automated tests for a component in the front end for various frameworks. Now let's talk about theming. So when theming apps, there is actually absolutely zero cases where we are designing the actual page or templates. But you want to, you're designing systems of components. So how do you do that? So you will first need some attributes or values. So we call them also here in this context design tokens. So the most common core values on web and also on native apps are typography, colors, and spacing. So these core values work very well together to create like a truly great and a very unique system as a result for your design. And in practice, applying the tokens on the button will represent basically the button in a way that like how it's specified in the system, and this is like a specification, and it's absolutely not tied on to one framework, and you can mix it to different frameworks and have the same design system as long as they stay compliant to your design system specification. One specific pattern that I'd like also to bring up now is when you create components that dictates the layout and spacings. So, for example, let's take a deep look into this typographic blocks. So you have you have a basic header, a simple header, 2 paragraphs, and when you specify spaces between the paragraphs, it's very common that you specify them on your paragraph. And in this case, I'm doing p plus p, but I've seen more often just a margin bottom on the paragraph level as well. And yeah, to be honest, I have only nightmare experience with them, since they can be barely moved elsewhere without having the correct spacing applied. I know there is margin that doesn't sometimes apply spacing on a wrapper, but you cannot assume that the wrapper is a flex box or is a grid that basically includes them, and it's very unpredictable. So what we want instead is to have a component that basically is for the layout, that like a wrapper or a container that controls the spaces between each child elements. So this way we can still move them out of the box and move something else in here and still have the correct gap space in place. And it's also worth to note that you can also compose these kind of things. So you can have these vertical spaces composed with horizontal spaces, for example, in the way you want. Now let's talk about building. So something worth to understand or revisit is the methodology of atomic design for creating user interface designs that are both modular and scalable. So yeah, think of UIs broken down into several things like atoms, molecules, organisms, templates, and pages, basically working together to create an effective interface design pattern. So it's a mental model to help us think of our user interfaces as both as a cohesive whole and a collection of parts at the same time. So, for example, atoms in practice are basically the smallest pieces possible in your application. So these are things like super primitives, such as just your very primitive button, or inputs, or your very standard heading, body text, cards, these kind of stuff, right? And then molecules basically composes these atoms together in its smallest fundamental units, like this search widget, for example, where you have your search input, maybe a label on the top, and then a button next to it, and the card in the back. And then you start grouping molecules, and then get organisms that represents like bigger sections, such as the entire top navigation bar, for example. Now, stitching more and more organisms together, you slowly get to create entire pages. So this is one of an example that represents one kind of a page. So basically a template. Now, when eventually we wanna distinguish different templates from each other, and you can do that even by putting representative content to the page, like different text or image or basically anything. So yeah, another thing, CDD or component-driven development is a common development process and strategy for building components. So it's a methodology that anchors the build process around components. And it's also it's a process basically also to build UIs from the bottom up, where you start at the level of your primitive components and your atoms, and then basically end at the level of your pages and basically on the bigger parts of your applications. In practice, you can apply the same methodology also on your per component level, for example. So basically, you build the box here at the bottom, and then follow up with maybe the value text. You know, add the font, add the colors, basically, or maybe the placeholder that's inside, and then you look into decorating them with an icon, with the search class icon, for example, and then after you add more granular logic and things on top of that, things like maybe a shadow or maybe some animations that you want to have when you hover or when you focus on it. Now, let's deep dive into some code. And I'd like to show you some super interesting things that I've learned over the past years when building UIs of a mid and to large applications. But before we get deep, here are some super quick wins that I'd like to sum up also for you, that if we keep this in our minds when building UI user interfaces. Basically, this has been actually recommended for now almost, or maybe even more than 10 years, and I think it still fits perfectly. So keep dump and smart or container and presentational components separated. Second, collocate related parts together. If you work with React hooks, for example, a great way to do that is by, for example, like building a custom hook that groups the logic together, if applicable. And yeah, try to keep the APIs as sensible as possible. And I'm also a big fan of not abbreviating too many things, because this also keeps it more readable to your colleagues if you work on building APIs. And yeah, try to reduce the API's surface to the bare minimum. Now, let's talk about React component props patterns. So this is a little bit React focused, but I'm sure there's still a ton to pick up for and take away for other UI libraries and frameworks. And I'd like to start with the bare Boolean prop. So here's an example of a button that specifies some primary styles. And you'll quickly note that by doing it like this, as a Boolean, it will become quickly odd when you try to add another Boolean of its same kind. So you cannot really do that, right? So it doesn't make any sense. So, well, there is actually a way, and it's actually possible when you use function overloads, for example, or typing that via a union prop types. If you do that correctly, you should be able to see an error by your TS compiler when using both simultaneously. But alternatively, and probably my most favorite case to handle this is by directly specifying it as a prop, as a union type or string literals. And yeah, here's a quick example of a button that uses exactly this as a string literal union. And in this case, it's a button with variants of button appearances. So the good thing about separating unions as a separate type is that it can be easily directly exported and consumed from somewhere else if necessary. So yeah, since both are basically possible and technically safe to do so, here's a comparison of some key differences that I've discovered. So I think that union type has less boilerplate when you try to get this auto suggestions from your VS Code editor, for example. So basically, you don't need to write complex, union types for two overloads also, and yeah, it has better auto completion as mentioned. What about dedicated components like this, and how do these come into place? So I've also tried to compare these things, primary button primary, and button appearance primary. And basically, if you use button primary, it's the best when the primary prop is being used to denote the primary action of the button, such as in a form where the primary button is the one that submits the form. So the primary button syntax can be used when you create a custom button component that is specifically designed to always have a primary experience, such as a button that's, for example, like always red, or that has a bold text. So this can be useful when a specific appearance is needed consistently throughout the project. And if you have the button appearance is primary syntax, this makes a lot of sense to use when you want to change just the visual appearance of the button, such as giving it a different style or color. Next, let's talk about enriching your components with types for standard HTML element attributes. So there's a variety of ways on how to enrich UI components with types of an element in React. So there is, React button HTML attributes, component props, with ref, without ref, HTML props, HTML attributes, and intrinsic elements from JSX. But they have all slightly differences, and I've used, I think, 90% of them, and the TLDR in my experience is that button HTML attributes is too verbose, or it's the most verbose here you can see, because it has the most characters. Then you have component props, which is not very specific about whether your component is using a ref or not. So you have one that prefers a ref, and then one that doesn't prefer a ref. And then you have still HTML props, and how do you differ that with the others? So I've discovered that these includes maybe a little bit too many types, even if they aren't, basic. Even if they aren't specified in this element. And then there's HTML attributes that doesn't actually include enough types, are not complete element attributes. And then there's JSX intrinsic elements, which basically errors when you try to use them inline. So most of the cases you have to wrap them with a non-nullable to be able to use it inline. And you won't have to do that and with these kind of things, because I think the most accurate and the least problematic types to work for me are basically these. And if you prefer not to be explicit, so there you can use component props. And if you prefer to be explicit with your ref, then use either with ref if you're sure you wanna wrap your component with a ref, or component props without ref. So these are the safest types, I think, that you can get. Now, exposing all the correct types is really, really awesome, but for building truly pure and robust UIs, it's not necessarily ideal to do so. And one of the favorite things, and I like to do, is to at least ban the class name and style prop to enforce more a consistent design system, as it allows individual components to be styled or to be modified in arbitrary ways. And this can lead very, very quickly to inconsistencies in your user interface, which can make it difficult to maintain and for users to understand and to use your application. So this is a quick example how I prefer to do. Basically, to apply the built-in omit utility type from TypeScript and just pull out any props as string unions that you don't want to have exposed in the second parameter. Or you can do it also the other way, to just pick with the pick utility type to just expose the ones that you want to have exposed to your components. Sometimes something that I totally encourage to do in React components is also to reuse existing and types and interfaces. So given you use like one single component per file, I can't stress enough to reuse and export types if necessary, so that updates to the exported or imported types are reflected automatically. That can save a lot of work and time down the line, and for me often it outweighs the work over when you start duplicating the types elsewhere. Here's also like a very, very quick bare minimum of a component that kind of outlines the most important things and how one of many of my primitive UI component look like. Basically, you have the types or interfaces for the component props on the very top, and then you have sometimes like some static variables or constants put even before that to keep props and components grouped together. And then inside the render block, you'll find like visual logic through, styles and class names, and sometimes hooks. And then you can, and then you get to the basically the render function. And here you want to make sure you want to keep it flat. You want to create you don't want to create nested if conditions. You want to create it as simple as possible and as easily as easily readable as possible. Now, to further enforce consistency of the design system in React, there's multiple strategies also to render subcomponents that should be themed in the same way. So you can think of it first as a compound component or as a polymorphic component. Compound components are basically a group of related components that are composed together to form like a large and more complex component that is basically allows for greater flexibility and modularity, as the individual components can be used and composed in different ways to meet the needs of different situations. Polymorphic components, on the other hand, are components that accept any different numbers of props and render them in different ways. Depending on the props that are passed in, this allows also for great flexibility and in how the component is used, as it can be customized, to meet basically the needs for every situation that you have by passing in different props. So overall, compound components and polymorphic components are both super useful approaches for building reusable components in React and can be used in different situations depending on the specific needs for your projects. So compound component is great for generally if you want to wrap an icon, or if you use polymorphic components. These are really, really great if you want to configure them consistently. Like, for example, applying the same colors for each component, but just using it like this. Now, let's check out generics and how they can come in handy in React components. So generics in components are a way of specifying the types of props that the component can accept. So they are great for better type safety and better type checking in the code, which can help to prevent errors and ensure that the component is used correctly. So this is like a quick example where I most often use it basically in forms, and basically the usage is like this isn't really necessary. And I tried I tried to avoid this syntax like this, but I thought it's nice, still to show and to know that you can actually pass generics also to your JSX components like this, like I do here on the right with sign-in form values. Now, let's talk about overload function components in React. A great way to enforce strict and complex types in React are by leveraging overload function components in React. So with these, it's basically possible to define multiple versions of a function that have like different signatures or set of parameters that you want to allow or disallow. So this allows for even more great flexibility in how the function or component can be used, as it can accept different types and numbers of arguments depending on the specific needs of the situation. Now, types or interface and props. So this is a fairly common debate. I think not only in React, but I think maybe even elsewhere as well. And on where others prefer this or that. But here is my hot take. So generally both are fine, and I actually use them both, but with a preference on interfaces. And here is why. So interfaces can extend other interfaces, which makes them slightly safer than, I think, intersection types, because it makes it impossible to accidentally overwrite anything, and it allows to enhance with additional members easily. that is useful when working with, you know, when you work with libraries that is not from you, so with third-party projects, because you can just redefine the type in a definition file and reuse them as they are. And type, on the other hand, they are, you know, they're more concise and easier actually to read than interfaces. And moreover, they cannot add additional members once defined, because, yeah, it is what it is, and which is both good and bad because of the better type safety. But based from my experience in the past with a mid to large project that I've built a UI component library for, I have experienced a slightly faster TypeScript compilation in the editor, actually, by switching hundreds, if not thousands, of components from type to interfaces where possible. And on that topic, I also encourage to type your return type annotations, especially function return types, as it helps with faster compilation as well, and it also can improve the type safety and correctness of your code, and it can make it much more easier to catch and prevent errors or, you know, wrong types. And I'm sure many people might not notice, but both what I just said with regarding the type, the interfaces and type annotations are even recommended in the official docs on a TypeScript repository in GitHub that you can check out. And yeah, it's pretty neat. So some more things on TypeScript I'd like to add is that I found so useful to have in the back of my head. So things like the any type. So not saying that this should be like totally you know, disallowed or you know, but I think it would be good that it can be absolutely discouraged. And you know, there is no way that anything should be, or there's, I don't know, there's almost no thing that anything should be really typed any, unless you really don't know and you really don't want to mess with your time more. But there's one thing that can be easily that you can do to get the types easily back is by adding a runtime parser like Zod if you expect something or expect a specific type, and then you can check it through runtime, which is helpful if you don't want to mess with this type, and you get the types back out of that. Next, type assertions, also known as typecasting, are generally considered to be bad for the following reasons, because they can lead to runtime errors as they don't actually check the type of a value at runtime. And they can make also your code a little less self-documenting, as they don't, you know, they don't provide specific information about the type of a value, and they can make the code harder to maintain and update, as they can introduce inconsistencies and errors that are not, you know, that are not caught by your compiler even. And to avoid these problems, it's generally better to use type-safe techniques such as type guards or type checking functions, and have correct types at runtime. And this can help to prevent the error, can prevent errors and ensure that the code behaves as expected. Do you have the same thing here with non-null assertions with the exclamation mark? So I think they are very, very similar. And yeah, better use maybe type guards or type checking functions and ensure that the correct types are there on runtime, even if it's sometimes a nightmare to add this like crazy code, but I think I prefer that over having incorrect types, because it can easily lead to errors that, you know, lead you to more time on development time. So yeah, with all that being said, I think it narrows down to definitely not forget about this rule on your tsconfig, strict to true. And apart from that, there is actually a bunch of super useful other flags that actually aren't included in strict. And to name a few, like allow unreachable code, allow unused labels, no implicit override, And yeah, this is actually my favorite one, no unchecked indexed access, which basically, when you try to access an index of a list, it adds an or undefined to your type, which is most of the time helpful because you actually can point to something that could be undefined, and yeah, but yeah, it is how it is. And now, yeah, with all that being said, it's helpful to keep those things in mind when building robust and resilient UI components. And those are the things that, for me, truly help me to build and keep consistency, stability, and type safety for my UI components. And overall, for me, like a peace of mind when thinking all of these. Now, before I finish my talk, I'd like to share some key takeaways. So first, proper setup of your tooling, such as linters, compiler, and testing frameworks, definitely help to increase developer experience and therefore help to write high quality and robust code. A resilient design system provides a set of standardized, well-defined components that can be easily integrated and reused throughout the code base, and encouraging the creation of robust code. Strict types help ensure that the data that you use in your code is valid and conforms to a specific schema, making the code more predictable and encourage basically the creation of building a robust code. Strict types also encourage the creation of not only code but also UI components by providing a clear, well-defined interface that ensures that the data is correct and consistent. And yeah, the key for building your user interfaces is simplicity. So simple components are easier to understand, maintain, and reuse, and are less likely to contain errors or cause problems in the user interface compared to your more complex components. UI components should, I think, be as possible as you can reusable to allow for easy integration into different parts of your user interface, and to reduce the need for reducing similar components or component that is, I don't know, slightly the same but still different. And yeah, it basically saves you time and improve code quality as well. And lastly, yeah, ensure that well-designed UIs from the beginning. So take good care from the ground up and ensure that the code and user interfaces are well-designed and maintainable from the beginning. Don't think of doing it in the beginning fast and then think of maintainability after, because it ends up often in a nightmare or maybe even on a whole refactoring. Yeah, and with that, you can prevent also issues and bugs from the rising future. Talk scared away. That's it. Thank you very much.